let Greg take a photo. Cool. All right. This is the DPIN or decentralizing and accelerating AI panel via decentralized compute. You've got an awesome group here who I'm going to let introduce themselves, but I want to set a teeny bit of context about what we're going to talk about. Recent advents in AI have created a huge demand shock for decentralized compute, or just generally compute, actually, and GPU. And so that supply-demand imbalance is being addressed by decentralized compute. But in addition, there are some like emergent properties in AI that can be improved or will have some challenges based on the use of decentralized networks. So we've got an awesome panel here to talk about it. We're going to go through intros really quickly. So Greg, you're nearest to me. I'll let you start.
My name is Greg. I am the CEO founder for Overclock Labs and a core contributor to Akash Network. Akash is the world's first open supercloud. A supercloud is essentially a cloud that sits on top of private, public, hybrid, whatever clouds you want, and gives you a federated interface to access these resources in a permissionless and a decentralized manner. And a key property is an open marketplace that allows you to trade resources. This is especially great when you have to trade GPU cycles. Turns out there's a lot of, while the demand for GPUs is super high, there's a lot of other GPU, there are a lot of underutilized GPUs, primarily from, downtime between training runs or, companies upgrading their fleets from older chips to newer chips. There's a lot of GPUs out there, so a network like Akash is bringing that to the light, and we are growing very, very fast in terms of usage.
I'm Ben, the co-founder of Gensyn. Gensyn is a decentralized machine learning compute protocol. We essentially connect up all of the machine learning capable compute hardware in the world, so GPUs, but also TPUs, CPUs, anything that's capable of doing machine learning training tasks, and allow that to be used as a resource by anyone who needs to train a machine learning model. And we view Gensyn as essentially fundamental infrastructure for the new machine intelligence web, essentially. So a protocol in the sense of TCP/IP or something like that. It sits underneath everything that we currently interact with, connects up all of the devices that are capable of doing ML training, and just allows that to smooth the usage of the compute devices that we have in the world. The future that we see for machine learning is complete ubiquity. It's going to be on every single device. Every piece of tech that we interact with as consumers won't be imperative code anymore. It'll be models, and those models need access to core resources. The one that we care the most about is compute, and so we're building the protocol to allow that to be instantaneous. So at any point in time, if a machine learning model needs to distill value in data into parameters, it can do that on literally any device, and it can burst out to happen on multiple devices when it needs to. So instead of training on a single GPU, you'll be training on maybe 1 million MacBooks or 1 billion iPhones or something like that. You as the developer or the user won't care or know that that's happening. It'll just happen as a protocol underneath everything.
Hey everyone, I'm Guy Wuollet. I'm an investor at A16Z Crypto. We were very fortunate to lead Ben and Gensyn's last round. I tend to focus on the crypto side, but we also have a team that is very focused on the AI applications as well, and we invest at every layer of the stack, be that infrastructure or applications within crypto.
Awesome, thanks everyone. So yeah, let's dive into it. The first question, Guy, as the resident VC on the panel, could you help set a bit more context, right? There's a long history of decentralized compute in crypto, or at least as long as there's a history of crypto. Could you maybe walk us to where we are? And then the follow-up question will be tease out like where we need to build more because prior decentralized compute doesn't address the needs of AI.
Sure, yeah, so I'll give the mental models and do the thought leadership, for lack of a better word. So I think a lot of this is really based on the pioneering work that Ethereum did to try to build a decentralized world computer. And in my opinion, a lot of the work that folks like Greg and Ben are doing now is trying to scale that decentralized compute to applications that are essential to inference, to training, to kind of every layer of the stack that's currently being defined in ML. And there were a bunch of different approaches and kind of prior generations around smart contract platforms where you would either explicitly form consensus through a BFT or a Nakamoto approach, and there are a bunch of folks that are focused on ZK proving for computational validity. A lot of those approaches don't scale, and they certainly do not serve the use cases that people are really interested in today for trying to inference a GPT-4 style model or train one in a permissionless way. And so I think a lot of the work that's happening now is essentially trying to address the very pressing question of how do we decentralize AI rapidly without relying on the techniques that are a little bit less scalable and have historically worked better for smart contract platforms.
And maybe this could go to Ben or Guy, whichever. Scratch one layer deeper, like architecturally, what are the needs of an LLM model that are different than like a DApp or a blockchain? Or Greg, you look like you're ready.
I mean, so there are different aspects of LLM, right? Be it training or be it inference or fine-tuning. So fundamentally, it comes down to the right amount of GPUs with least amount of friction to the user's GPUs and overhead to using the GPUs, right? So if you go with the traditional verifiability in all aspects, it adds a layer of like complexity that affects the performance, right? And along with just chips, you need the supporting infrastructure, be it storage, be it bandwidth, be it a professional grade data center that can offer, right? A machine sitting in a home may not be able to serve a production workload unless maybe intelligently designed with asynchronous model, but definitely for an inference type of scenario, you need that low latency access to the user, and that can only be delivered by a professionally managed data center. So that tends to be a big barrier. And one of the things Akash does is hyper granularity in terms of scheduling your workloads. So in the sense where you're in a smart contract machine, the system does the scheduling for you, and the user has very little say, of almost no say on where your application is running. So it's a different way, it's a different pattern of deploying. Great for like deterministic approach of applications, but for when you have non-determinism and you have low latency requirements, your provider has to have that sort of like capabilities, and the system should have the granularity to select the provider. And that's, I think, the big difference between something like Akash or a fully deterministic on-chain execution layer.
Awesome. Ben, anything to add?
Yeah, I think I'd probably just say that the different use cases within ML have different requirements. So like inference has a completely different set of requirements to training. And I think that's where something like Akash, like you can do loads of different tasks over that network, and you can do inference, you can do training, you can do things like this. But ultimately, underneath each of those tasks, there are fundamental bottlenecks that if you solve them in a thin way, you can potentially accelerate those things even more. So we focus purely on training and solving the verification problem, which in our opinion unlocks massive scale for compute. But there's plenty of other things around compute required for training models. There's like data, there's latency, as Greg mentioned, there's general usage. Like that's a kind of problem that if you are deploying machine learning models at scale, you're going to need usage. And I think the ML world's gone through various phases of focusing on one of these specific things and thinking that's the value unlock. And we've moved through various of these with like data being the new oil for a while, and then kind of like PhD students who can build models being the kind of value, then to compute itself, if you can hoard it, that's the value. I think realistically, each of those things is required, and as a kind of community, we've gradually moved each of them up. I think the future is creating a modular system where we solve each of those problems as a separate network, and then we sit them all together. And then out of that, we get the real unlock for the future of ML, rather than kind of like iteratively reaching each one up a little bit at each time.
Okay, awesome. And so what I'm hearing, and I guess like one of the overall questions I have in the first section is, like right now, because there is a supply-demand imbalance, like anyone who can get their hands on GPUs to do work is going to shop for it and going to go where they can even get it, let alone at a better price, right? But we're going to reach a point where there's a certain scale in the market of available GPUs. Like how do we, and can we, or is that even the goal, get to a point where decentralized networks can compete with centralized, like hosted data centers like those at AWS or Google Cloud?
Yeah, I think from my perspective, decentralization improves that market. So in the long term, it makes it the most efficient way of accessing compute and the cheapest cost way for the demand side, the highest yield way for the actual owners of the devices themselves. Currently, the market's captured by middlemen. So there's particular reasons within the market why you can extract rent from a different portion of the stack. And I think what decentralization does is just eliminate those portions. It stops there being a way to extract rent from halfway up the pyramid and just allows value to flow all the way down to the end. So ultimately, it becomes the lowest price, highest scale, highest access way of distributing things like compute, but also things like data. Like all of the core resources required for ML can have this new business model essentially floated on top of them, and they can generally just open up access to that. And I think we're all aware of like the social reasons why we think we should open access to ML. Like we've seen Gemini, etc. Like the world has come to it from a social angle, and now we need to come to it from a technical angle and actually build the new incentive structures for it.
Right, so the spice must flow, right? So we're going to fix the supply chain problem at some point, and there's lots of investment going into fixing the supply chain problem, all the way from building foundries, all the way from attracting new talent, and a lot of good things. But what interestingly is we have an opportunity right now, right? The question is, well, once the supply chain is fixed, you get the economies of scale that large, hyperscalers have that, may overpower the network, right? So I think we have maybe about 2 years to really decentralize because we have one thing the hyperscalers don't. Like Akash is the only place to get on-demand H100s right now, and there's no way you can get that H100, and that's going to be not forever, right? So I'm building a data center in my house in Texas. And with a come and take it flag in front of it. And that's going to be about 40 kilowatt solar powered. It's going to pay for the house. So I think, we have an opportunity now. And people are going to use my GPUs that are in my house because you have no other option, really. So we have a great opportunity. And we have one thing crypto is phenomenal for is incentives and gamification of usage. So how do we leverage that opportunity and how do we get maximum impact in terms of attracting the most distributed supply? And there are a lot of research. I mean, there's a recent paper by Google DeepMind, Doloco, right? It's a very incredible paper that talks about a big challenge with training is, latency. And there's a lot of really good people working on solving the latency problem using different mechanics. And Ben is a lot more has a lot more expertise than me when it comes to like reducing that stuff, but it's a lot of promising work. So hyperscalers are not going to be the only ones with that massive advantage, and we have a great opportunity here.
Yeah, I think there's a particularly unique opportunity here because crypto projects often have a much harder UX, and it's more difficult to convince people in the traditional world to onboard. And because there's such constrained supply today, people are willing to make a greater leap or to, as you were saying, Greg, use GPUs in your garage, where maybe 10 years ago, folks at a Fortune 500 company would have been a little bit more skeptical about that idea. And so I think this is kind of a unique opportunity to have the world by default run on a decentralized network as opposed to by default on a centralized network. And a theme that I think comes up time after time in crypto is that we are all in some sense betting on the creativity and the ingenuity of everyone around the world, and saying that we want not just a small number of companies and a small number of very smart but credentialed people to propose how society is run or the systems that coordinate our lives. We want anyone to have the opportunity to do that. And my hope is that things like Akash and Gensyn and other projects building in this space will make that the default as opposed to something that we need to upgrade to in the future.
Yeah, it's an interesting point, and another topic I wanted to dig down on, especially for the founders, right? How do you think about permissionlessness in this category? It's an ethos of Ethereum for sure, and as a censorship resistance. But in this category, it certainly comes with challenges, not the least of which, though I don't totally understand the nuances, is export controls around certain devices like H100. So how do you think about a permissionless network versus not? And if you don't want to talk on this topic, that's fine. But how do you think the world should think about building like permissionless compute networks? And then one follow-up question on that one once we get going.
I can take this. I mean, permissionless is a foundation for composability. I mean, removing barriers of usage improves adoption to a point at a rate that closed systems cannot, right? So permissionless is foundation for Akash. Censorship resistance is foundation for Akash network. That's never going to change. But the challenge remains abuse. Abuse tend to be a problem. I mean, one thing is about policy restrictions, but another thing is about using AI for really bad things, right? So how do you prevent that? Well, it really comes down to liberty, right? As much as users need no permission to use Akash, the providers also have full control and sovereignty as to who they should allow to use the network, right? If the provider doesn't want to serve a user, they can very well shut down the user. They can just stop, not shut down the user, but can stop serving the workload. And the user, as long as there's another provider that's willing to serve their workload, they should be, able to. So if there's something really bad like child pornography or something, nobody wants to host, nobody's going to host. But if there's something that falls on a different side of the political spectrum that half the country may not agree, but half of them do, yes, that'll be served, right? That's how we look at censorship resistance and moderation, right? It's self-moderation. Moderation is done by the providers and not by the protocol. And the protocol should remain free and free of moderation, free of censorship, and permissionless. That's the only way to go forward. And like permission models and closed models can go fast in the near term, but open and permissionless models can go far in places where traditional software cannot. Like one of the examples I give is Akash is being used by DoD, Department of Defense, because of its open source nature and permissionless nature. Of course, a fork of it, not the actual network, because DoD cannot use external servers, but they're using internally to consolidate their supply, and they're running their own fork. But that just tells you, and we have zero salespeople focusing on even corporate America, let alone defense, right? But that's the kind of organic adoption you get when you have really open source software, and that's the kind of stuff that is critical for massive adoption.
Yeah, I'd probably just say we have basically the same view as Greg has just described. I think foundational technology should be neutral. Like if you create the checks and balances within the foundational technology to allow somebody to disallow something, you just create an ability to control that technology, and that will be abused at some point. So you'll create the ability for power to accrue within the technology itself. We think that at the lowest level, when you're building these primitives, you need to build them to be entirely neutral. And society is going through some really interesting governance alignment questions right now around AI. We're going to have some difficult questions to answer about how we collectively govern the things that people can do with this technology that enables massive leaps forward in various things. Those can be leaps forward in bad things and good things. And obviously society has an Overton window that moves around. I think at different points we'll need to do different governance actions, but they should all be done through social governance mechanisms and through arguably the mechanisms we already have to govern applications themselves. But the technologies underneath just need to be completely neutral. They should be usable by anyone at any time. And then when somebody uses those things to do some bad in the world, we go straight to the application itself. So if somebody builds an application to do something that we all agree is actually shouldn't happen, it's the application that's at fault. It's not the technology underneath. We've been through this battle before with encryption. We all probably agree that encryption shouldn't have backdoors in it just because there's bad things you can do with it. It's the same for ML. It's the same for compute. It's the same for data networks. These things shouldn't be backdoored because those will be exploited by people to accrue power. And then we've lost the real value we can have from decentralized technologies, which is to just level the playing field completely and level up society as a whole rather than a small portion of it. It's why the Gemini stuff, I think, has resonated so strongly with people, because you see the bias of a certain group being shown to everybody very, very clearly. And we have very few choices around models that we can use right now. So people are forced to use these models with biases that they don't agree with. Realistically, every ML model is biased. Like every technology we build is biased. Like they're all biased machines. We're biased machines. But what we need to do is build technology that allows all of those biases to come to the front, and then people can choose which biases they use. So it requires neutrality at the absolute bottom layer.
Okay, you answered. Oh, sorry, go for it, guy.
I think Ben said it very well. Go ahead, Stephen.
Yeah, I had a follow-up question, but you also answered that. It's like, where does the red button go? Like AGI takes off, we need a red button. GPUs seem like the right place for the red button. Maybe we don't need a red button. I assume you disagree with the premise.
Well, so Akash in Sanskrit means the sky, right? It's where the clouds are formed. Akash net, if you translate that to Skynet, that was not by design. It was pure coincidence, right? Like those of you old enough to remember what Skynet is, it's essentially the AI that kills us all. So I'll be more concerned about self-replicating machines more than government and policy shutting us down. And incentives are one of those things that if you perfect them to a point where machines themselves can create incentives to further attract more supply, what's going to stop, right? Like, what's going to stop like an AI to trade Akash token and maximize its gains and use that to purchase compute? You can do all kinds of things, right? So the way I think of it is, I think proof of personhood could be a potential solution in the future, and because Akash is a proof of stake network, it's managed by human beings at least as far as I know. And humans have a vote in the system, although there's no way to know if it's a human behind the vote or not. And ultimately, the stakeholders of the network will eventually determine what kind of access and who to allow access to. But that's the beauty of open systems. Let people decide. And we don't know what the solution is going to be, but I believe in humanity.
I think that's the big point, right? You believe in humanity and you believe in these structures that you've built that have agency right at the lowest level. So like you said, Greg, like if a compute supplier, if somebody's putting GPUs online and they see something that they don't want to do, there's a computational task that comes to them and they say, I don't want to do that. They don't need to do that. And that's how society can control these things in the future. It doesn't need a big red button in the middle. It needs people to do in the moment what they think is the right thing to do. And actually that's a better reflection of the whole of society than having a small group with a red button that decides on behalf of society. And it doesn't require us to have this kind of like governance, kind of democratic voting system, because it's actually just the users of the network are the suppliers of the network, and they vote by just withdrawing their supply or not doing the task that they would otherwise be incentivized to do. So I think it's a much truer reflection of our collective thoughts as a society to just give people the control, rather than saying they have kind of proxy control via voting for a small group who will then slam this red button when either something bad happens or something that group disagrees with happens.
Yeah, so I'll speak for myself personally here, but I think the big red button question is often like, what if things move too quickly? And I think the inverse of that question is also worth asking, of what if we don't move quickly enough? The world has a lot of challenges, and I think drastically increasing the amount of intelligence that can be applied to those challenges, I believe would be a very strong net positive. And so usually people, we'll have the slow takeoff, fast takeoff debate, which is probably out of scope here, but I am very much on the side of, what if we don't move forward and continue to build great new things that create a better world for humanity? And that's the question I would hope that most people come away asking, instead of being a little bit more fearful.
Awesome. Good answer to a silly question, all of you. Okay, so we're getting here on time. I sent you all a lot of questions, and this was the last one. You're all very busy, so I'm not sure if you read to this point in the prep questions. But we'll start with Guy. What was your favorite GPU, and why?
Oh.
Interesting. I did not read to this question. I actually don't even know what it would be called, but I had like a first-gen MacBook Pro that I used to play Rome Total War on, and whatever that GPU would have been was my favorite.
Sweet.
Probably a similar answer. I don't even know what it was anymore. I can't remember. It wasn't even PCI. It was some other slot that doesn't exist anymore. Some ancient thing that I think somebody found in a second-hand shop to put in the PC because I thought it would allow me to play games. I don't think it actually even did. But to me, it represented that access to the gaming world as I don't even know how old I was, very young child. So similar answer.
4090, hands down.
4090. Oh, you're a modern guy.
It's
modern.
versatile. It's beautiful. It works really well. You can play games on it, and you can train AI or not train, at least infer. It works really well. If you know how to optimize your pipeline, you can do a lot of damage in 4090. Surprisingly, 4090 has been like popping up like a lot now. People want more 4090s than A100s. Because a lot of the papers are mentioning 4090s. I think 4090s is going to be one of those what do you call, under the radar that's going to pop up and become the most important GPUs. I have a bunch of 4090s at home that are making about $250 a month.
Shilling the bags there.
I'm shilling my own bags,
Awesome.
4090 NFT drop now.
Well, thanks, guys. Mine, I cheated. I looked up. Half-Life came out, and I bought a Radeon 9700, and it made Half-Life absolutely dope. But I cheated and looked it up. Awesome. Well, I really appreciate the discussion. This is great. Everyone, thanks to our panel, and we will see you at the next one.
Wonderful.
Thank you. Thanks.